we reach the edge of present understanding. Are these some quarks in intense interaction? As a single proton fills our scene, so massive and so small, at last the carbon nucleus. There are protons and neutrons in every nucleus. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules on a vast inner space. At the atomic scale, the interplay of form and motion becomes more visible. Now we come upon the 2 inner electrons held in a tighter swarm. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. Electrons in every atom. Atoms bonded into every molecule out to the farthest galaxy. A molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. Among its vital organelles, the porous wall of the cell nucleus appears.
The chlorophyll is stored in these egg-shaped structures visible at the center of the image, which are chloroplasts. More precisely, it's kept in these strange and regular piles. Photosynthesis takes place here. This is where the plant produces the sugars it needs and the oxygen we need. Before we get into the structure of the leaf, we move along a first layer of superficial cells. The hairs which cover leaves and veins are special cells. You can see the veins running through the leaf. They prolong the stem and constitute the irrigation system. A familiar plant whose unique aroma has made it a cherished ingredient for cooking all around the world.
A scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Cars crowd the highway. 100 meters wide, the distance a man can run in 10 seconds. This square is 1 kilometer wide, 1,000 meters, the distance a racing car can travel in 10 seconds. 10 to the 4th meters, 10 kilometers, the distance a supersonic airplane can travel in 10 seconds. Our picture will center on the picnickers, even after they've been lost to sight. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1 million meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide in their big orbits. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This squares 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The 2 little satellite galaxies of our own are the clouds of Magellan. 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars. Whole galaxies of stars, seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. This lonely sea, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception.
To witness the birth of the universe, vast, empty, and as far as we know, lifeless, and experience the fury of cosmic missile attacks, feel the bitter chill of global ice ages, dive into oceans full of bizarre life forms, ride continents on a collision course, face killer dinosaurs. Deep in the Earth's past, to see for ourselves the first humans walk the Earth.
Fire. Our first true piece of technology. Such a very long time ago. Which begs the question, what have we done now? 100,000 BC, stone tools. 4,000 BC, the wheel. 800 BC, sundial. 9th century AD, gunpowder. 1441, the printing press. 19th century, steam engine, railway, eureka, the light bulb. 20th century, the automobile, television, nuclear weapons, spacecraft, internet, all because he gave us fire. Our first true piece of technology. We wield incredible power. The power to transform, to destroy, and to create again. Which leads to an obvious conclusion. We are the gods now.
1 cycle per second. The pulses become more frequent as the rhythm picks up pace. 10 cycles per second. First a rumble, then sub-bass. 100 cycles per second. And after that, tone with an ever-rising pitch. 1000 cycles per second. Eventually the rising tone becomes a very high-pitched chirp that fades back into silence. 10,000 cycles per second.
We enter the world of radio waves. Radio waves cover a huge stretch of the spectrum, from wavelengths of 1 meter or so to radiation with wavelengths of over 100,000 kilometers. We're used to thinking of radio as something we listen to, but that's because the sound from the speakers has been sent to the radio set by wireless, radio waves from a transmitter received by the set's antenna. But radio waves are as much a part of the spectrum as visible light. Radio sets receive waves from a transmitter, but we can build equipment that detects natural radio waves from deep space. Move further along the spectrum again. This is the world of microwaves. Microwaves are familiar. Many of us have microwave generators in our kitchens. This light has wavelengths from a few millimeters up to a meter or so. They're called microwaves because although their wavelength is so much longer than visible light, they're still only measured in millimeters. Beyond microwaves, and we reach another type of radiation, the far infrared. We can sense these waves. We feel them as heat, and use heat-sensitive cameras to make images of this world. The camera can still see the scene, but it's lit only by infrared, and looks very different. Of longer wavelengths beyond red, where the waves are invisible to our eyes.
In 10 seconds. There it goes. From here on.
This must be from invisible light beyond the violet, so he called it ultraviolet. As the wavelength shortens even more, we've now reached the domain of X-rays. And the shorter the wavelength, the more energy the rays have, which gives X-rays some very strange properties. X-rays pass through solids because their wavelengths are so short they have very high energy.